Hey, when you had your like, yes, my first and last week off. Good. Wait, was you actually? Was there anything? Yeah. Why did I say fall behind by so much? Then when we're here, we just stop. The other thing. There's definitely, like, there's a little bit above that.
All right, good morning, everyone. Today we're just going to do another day of review for our quiz tomorrow. So trig derivatives on the first page, related rates and inverse trig derivatives on the second page. So we're just going to practice through these problems in preparation for tomorrow. Okay, all right, so take a look at number one. Y is equal to cosine cubed pi x squared. All right, what's involved here?
Chain rule.
Get chain rule. But before we jump into chain rule, what should we do that could be helpful?
Put in brackets.
Yeah, let's get that bracket to show up, get that cubed outside those brackets. And that's going to help you identify what you need to see. All right, so spend a minute, see if you can work your way down to the answer. Okay, so here's the outside portion. Inside is the cosine parentheses, and the inner portion is that pi x squared. Okay, we're going to take turns finding each derivative, and they're each going to be in a separate space apart from each other, right? We don't want to insert these derivatives inside each other. Okay, y prime. Power rule for bracket cubed. 3 bracket squared. Insert into the bracket the original expression. Check that off. Next up is cosine's derivative. Cosine's derivative is negative sine. Insert the original. And finally, the inverse derivative, pi x squared becomes 2 pi x. However, you could choose to just finish off this rule here. Negative sine of pi x squared times 2 pi x. So either you apply that u prime here, or you do the inner here, but it's only going to show up once. Okay, it's a duplicate, so you don't want to do both things, either one or the other. All right, any questions here? So this form is fine. I like to clean up those, so I'm going to try to push all the coefficients in front, the non-trig expression portions out in front. So 3 times -1 times 2 pi x. The bracket squared is fine, but I'm going to bring it back down. I just want you to know what the cleaned up version looks like for if this shows up on the final exam multiple choice or AP exam multiple choice. Your answer choice will look like that. But on the quiz tomorrow, you can leave it in this form. All right, any questions with chain rule and the process there? Okay, number 2. It says evaluate y prime of 0. So what's our involvement here? Quotient rule, yeah. And what is that y prime of 0 telling us to do?
Find the slope at 0.
Yeah, so we're going to evaluate the derivative, right? So you're going to find the derivative function and then replace all the x's with 0 and then get down to a number. And that number will represent slope. My suggestion is as soon as you find the derivative, don't worry about trying to clean up the derivative. Just replace all your x with 0. It's going to be long and messy, but plug in 0. As soon as you find the derivative, will just help collapse your answer down to a number a lot faster, rather than trying to clean up or factor or cancel out. Just replace all your x's with 0s. All right, give that a try. Let's see how your steps look. Okay, numerator is my f, denominator is my g. Going through quotient rule here, f prime, sine pi x becomes cosine pi x times pi. We keep the original g function, minus the original f, g prime, cosine of u becomes negative sine of u times u prime, all over denominator squared. Okay, any questions up to that derivative portion? Okay, next step, replace all the x's with 0. So 0 times pi is just going to be 0, right? So everything inside the parentheses will just turn into a 0. So we got cosine of 0 times pi times cosine of 0, minus sine of 0 times negative sine of 0 times 2 pi, all over cosine of 0 squared. All right. If you want to enter this in the calculator, make sure you're in radian mode. Cosine of 0 is 1, sine of 0 is 0. So 1 times pi times 1 is just pi. 0 times 2 pi is just 0, all over 1 squared, which is 1. So the slope at x equals 0 is just pi. Okay, any questions? Okay, does anybody still need to look at number 2? No, okay, all right, here's number 3. X cosine y is equal to tangent of y minus 3x. Okay, so 2 things I want you to notice. What's involved here?
Implicit.
Good. Implicit and product. Yeah, implicit because the y's, product rule because of the x cosine y. All right, try that. Okay, so the implicit portion of this problem, we're expecting some dy dx's, right? So you see how you have 2 y's in the original equation. So we're expecting 2 dy dx's with our derivative y. Okay, first up, product rule. F prime, x becomes 1. G function stays. Back to f. And then cosine's derivative is negative sine of y, but we're asking for y's derivative, so our first dy dx will begin to show up. Okay. Tangent of y, secant squared y. This is our second dy dx will pop up here. And then minus 3x becomes minus 3. So this is the only calculus step in our problem. The rest is just trying to clean up, trying to get that dy dx variable by itself. I'll get these two terms on the same side of the equation so I can take out that factor of dy dx. Factor dy dx out. Divide the parentheses over. Okay, so this answer is acceptable. There's a cleaned up version of this though, where if I multiply everything by -1, numerator and denominator, it'll take me to where everything is positive. But either is fine. Okay, any questions with the steps here? Okay, while you guys are finishing up on that, if you guys can take a look at number 4. No questions with 3? Okay. All right, take a look at 4. I'll talk about that in a second. Okay, is anybody still needing to look at number 3? No, okay. Okay, all right, here's number 4. Find the equation of the tangent line. So what information do we need to get tangent line equation. And
The y.
Yeah, yeah. So in this case, they only gave us the x, so we need the order pair. We need the y as well. Good. All right. So let me list that out. We need to find the order pair. We need to find the slope, and then we can dump it into the point slope form. All right, but before we try to find any of that information, what is a good first step?
Chain rule?
Yes, chain rule, but before that, yeah, let's just rewrite this, right? That exponent can be put in a more helpful location for us. Otherwise, it's easy to make a mistake. Right, I'm going to start off by looking for my order pair first. So I'm going to just use the power of 4 and see what my y value is. Okay, use your calculator if you like, or think about your special values under trig. Tangent to the power of 4 is just 1. 1 cubed is 1. 1 times 2 is 2. All right, next up, we want to find the derivative, but you guys mentioned chain rule. So we need to find an outside and inside portion to build from. Try that first. Okay. Outside is the 2 bracket cubed. Inside is the tangent of x. Take turns with each derivative power rule for the 2 bracket cubed. We insert the original within the bracket. And now we're ready for the inside derivative. So tangent's derivative is secant squared. And then the u and u prime is just x, so times 1. It's not going to create anything more than that. All right, good so far. Next up, we need to find the slope. But I think something that can be helpful is let's get that secant rewritten as well. Replace all the x's with pi over 4. Okay, all right, let's think about these values here. 6 days, tangent of pi over 4 is 1. 1 squared is just 1. All right, secant of pi over 4. I like to think in terms of sine, cosine, and tangent. I know secant is related to cosine. So what's cosine of pi over 4?
25.
It's going to be root 2 over 2. Root 2 over 2. So if my cosine is root 2 over 2, then my secant is just the flip version of that. Right? Okay. Square everything inside. I get 4 over 2, which is 2. 2 times 6 is 12. Okay. Got my ordered pair. Pi over 4 and 2. Got my slope. And now point slope form. Y minus 2 is equal to 12 times parentheses x minus pi over 4.
Mr. Yang,
Yes.
so on the left side, when it's y pi over 4 equals 2 times 1 cubed equals 2, the one right below it.
Right.
How did you get that again?
So we're just cubing the 1, but we're not cubing the 2. Tangent of pi over 4 is 1. And then 1 cubed is 1. 1 times 2 is still 2.
Okay. Thank you.
Okay. Any other questions with number 4? Anybody still need to look at number 4? Okay. All right. Back page. Our trig. So this one is pretty straightforward, right? There's no product rule, just really a little bit of a chain rule involved, but really it's just kind of matching the rule for arctangent, identifying the u value, and then just plug in. Try that. Make sure that you're squaring everything inside the u expression. We don't want to just write as 2x squared, right? You got to make sure you put the parentheses around the 2x as a reminder that exponent is going to see both those terms inside the parentheses. Yes.
So why is 4x still to the power of 2?
The reason why is because the rule is asking for u squared. So we got to take the entire u value and square it. And then when you get the entire u value squared, that exponent is going to distribute to both of these inside my parentheses. So 2 squared.
Yeah. Gotcha.
Yeah.
Thank you.
Okay. Any questions with 5? 6 is the same way, but let's come back to 6. If we have time, we'll do it at the end. But really, you're just identifying your u value and you just plug it into the arcsecant rule. Okay, so let's skip down to number 7. Let's try number 7. Inverse cosine is the same thing as arc cosine, just different way of writing it, but it's the same thing. Okay, what do you notice with 7 here? What's involved here?
There's chain rule.
Good, chain rule. Okay, so find your outside, find your inside, go from there. Okay, take care of your outside first, and then in a separate space, you can take care of the arc cosine derivative. Right? Parentheses squared becomes 2 parentheses to the first power. Insert into your parentheses or bracket the original expression. So once we have the outside taken care of, we can move on to the inside. Inverse cosine looks a lot like arc sine. Negative u prime over square root of 1 minus u squared. This portion is fine. I'm going to clean up, so this is my answer. Questions with 7? Okay, anybody still need to look at number 7? Okay, let's look at number 8. This is the related rates problem. All right, a camera on the ground is 100 meters away from a model rocket launch pad. When the rocket is launched, it rises at a constant velocity of 20 meters per second. How fast is the camera's angle changing when the rocket is 100 meters high? So we know all these are going to be right triangle related, so we can just draw the same right triangle diagram for all these problems. Camera is here, launch pad is here, and the rocket is going to rise in this direction. So theta goes here. We know the distance between the camera and the launch pad is not going to change, so 100 meters. However, the rocket will continue to rise, so that's going to cause this distance to continue increasing. So we don't want to put a number in for that, right? That's going to be a variable. I'm going to use y. All right, so now based off of this, we got to choose a trig equation that's going to be most suitable. So sine, cosine, or tangent? Tangent. Nothing about hypotenuse is given to us, so we have to rely on opposite and adjacent, so tangent. Now, if these were both variables, we'll have to go through quotient rule. But in this case, we can just pull that 100 in front and just do some version of power rule. Okay, we're ready for the derivative. Now, we're talking about related rates here. So every variable is going to be impacted. What's going to show up with every variable?
D over dt.
Yeah, d over dt, right? So we're expecting d theta dt to show up. We're expecting dy dt to show up. Okay, so tangent's derivative is secant squared. One over 100 is just a coefficient, and then y becomes dy dt. Okay. We know that our answer is just going to come from this equation, but we still have some missing pieces, right? So let's go back to the problem and see what information we can gather. When the rocket is launched, it rises at a constant velocity of 20 meters per second. So what can we assign that number to? Dy dt, right? It's the rate of change of this y variable here. How fast is the camera's angle changing? So we know angle changing, that's d theta dt, right? When the rocket is 100 meters high. What's that 100 referring to? The y. Now, it's a y value at a moment in time. It's not this y value, right? This y value, we're holding on to that variable, but it disappears. So this 100 is not going to be used directly into this equation, but we are going to see a use for it in a second. All right, let's revisit our equation, see what information we have. Dy dt, we now have a replacement for that, right? D theta dt, that's what we're looking for. So, but the unaccounted information is that secant squared theta. So we need to find a suitable replacement for that secant squared theta. And this is where we're going to build a second triangle and try to find a ratio for that secant theta. Here's my second triangle. We know the 100 is going to stay. Okay. What is the vertical in the right? So now we can use that 100, right? That 100 basically taking a snapshot of that moment in time when the rocket is exactly 100 meters above ground. Pythagorean theorem gets you to the hypotenuse. A squared plus b squared equals c squared. Or if you recognize this as a 45, 45, 90 triangle, we know it's 100 root 2. All right, so now we should be able to find out a fractional value ratio for secant theta. What's secant theta going to be?
Root 200 over 100, or 100 root 2 over 100.
Good. Hypotenuse over adjacent, right? We know it's just a flip version of cosine. Cosine is adjacent over hypotenuse, so therefore secant is hypotenuse over adjacent. Okay. And what does this reduce to be?
2.
Root 2. Yeah, eventually it'll be 2, but yeah, right now I'm still going to leave it as root 2. All right, so now we have something to replace that secant squared theta with, and we should be in the clear, right? We should have everything we need to get to our d theta dt. Okay, so secant squared theta, that's same thing as root 2 squared. Okay, 1 over 100. dy dt is 20. Root 2 squared is just 2. Divide 2 from both sides, or you can think of it as multiplying by 1/2. Clean this up. 20 over 200 reduces to be 1 over 10. And what's our unit of measure?
Radians.
Good. Theta is always radians. Time, in this case, is seconds. Okay, any questions with 8? Okay, let's go back and finish number 6. You can leave your answer unsimplified. My u value is x over 4. Your u value is 1/4 times x. One-fourth x becomes 1/4 with a negative in front, and the 5 is just going to attach itself in front. Ask the value of u. x over 4, square root of u squared minus 1. So this is fine. But I'm going to go ahead and try to clean this up a little bit more. I see the 4's can cancel out. Common denominator, I can make this x squared minus 16 over 16. Root 16 is just a 4, and then the 4 in the denominator of the fraction is just going to be flipped to be times 4 with a -5. And then we leave the absolute value if there's any x's left over. So in this case, the x is still going to remain. It's not going to cancel out, so we need to hold on to that absolute value. But either is fine. But multiple choice, this is how it's going to look. Okay. Any questions with 6? All right, a couple of announcements, reminders. Okay, quiz is tomorrow. 6 problems. Chapter 5 recovery assignment is due tonight by midnight. This is to be eligible for the Chapter 5 recovery test if you choose to do that. You recover up to an 89. And then any student can recover up to an 89. And so that recovery assignment includes test corrections, turning in your classwork homework, and then also the assignment from the textbook, where the link is there under that team's assignment. Your Chapter 5 recovery test is Wednesday. So after you turn in your recovery assignment, you're going to let me know whether you want to do the 7:15 or the 4:30 p.m. time slot. And all this is on Teams. So this is none of this is face-to-face. These are all on Teams. Okay, finally, I have a help session, 5th period lunch, 3:30 p.m. this afternoon, and then tomorrow morning, 7:15. I'll go over the morning review, 3:30 as well, students who can't make that morning session. So I encourage you guys to work through that morning review worksheet beforehand, just as a way to see if you're able to do everything from scratch, right? I think it's a good thing to do. And then tomorrow morning, if you need additional help or you want me to go over the problem or if you have some specific questions, I can help answer that. I also included under today's link the Trig summary sheet. You may find that helpful to print that out and have that have the access to that while you're taking your quiz. Okay. Any questions? All right, so this is the final assessment, required assessment. Your is optional. You can exempt out of that. It's not going to hurt your grade. So this could be the last grade that goes in the grade book for you. All right, if you have, let me know if you have any questions. Reach out to me through Remind if you have any questions. Hopefully, if you need help, I'll see you in the help sessions. Otherwise, have a great day, guys, if you're on Teams.
Thank you.
Thanks. Bye.